I made this integral in the process of evaluating this sum. So in case you don't know how I got from this sum to this integral, then click the link above. Meanwhile, we have work to do. Let's get to work. So let's say x over 4 becomes sine squared theta, so that we can say that x on its own is equivalent to 4 sine squared theta. Now, of course, we're going to take derivatives of the both sides. So we have that this is 4 times 2 sine theta cos theta, which in turn d theta gives us 8 sine theta cos theta d theta. Now it's time to make this the subject of the formula. So theta is equal to the arcsine of the square root of x over 4. So we're going to use this to identify our new interval right now. So for here, making substitutions, I have that for when x is 0, theta on its own part after the evaluation would end up becoming 0. So when x is 1, theta on its own part after the evaluation would then become pi over 6. With all these backups, I'll go ahead and transform my integral. So now I have that s is equivalent to the integral from 0 to pi over 6. We have 1 over square root of 1 minus. Now remember, we'll give this a new meaning, so we're going to change it now. We have sine square theta. Okay. So the rest of the expressions come in now. But remember that x is no more x. It is now 4 sine squared theta. So let's substitute. And here also we'll do the same. Alright. No, not dx this time. But remember, dx is equivalent to, or rather, let me make this more clearer. Dx is equivalent to 8 sine theta cos theta d theta. So I'll just fix it here. Now this can take good care of this expression down here, then the rest of the integrals can come in. Now I'm gonna use 8 sine theta right here to multiply this bracket so that each expression inside that bracket will have its own integral. Oh, pardon me, that should be sine squared theta. Wait a minute, there was a half here all this while, and I skipped it. Wow. Alright, so now, introducing it, I have now I'm gonna take the individual integrals one by one. So let me name this one A, and the next B, and also this one C. So I'll be having something like S is equal to A minus B plus C. So let's take the first one, A. Now remember that the integral of sine is negative cos. Substituting the intervals, I have now take note of this equation. We'll use it later in the future. Oh, there should be a 4 here. Sorry. So this is the value of the integral A. Alright, let's go to the next one. Integral B. Now note that here there's a sine cube theta, so in its expansion we have that sine cube theta is equivalent to this expression. Now with this power reduction technique, we're going to transform this integral, having sine cube theta, using this expression here. So we have that this integral right now we'll then take a new look. Now note that when you're integrating sine k theta, you'll be having negative 1 over k cos k theta. (32/4) is 8. Evaluating it from 0 to pi over 6. Now remember that cos pi over 6 is equivalent to the square root of 3 over 2. And this is what the integral b gives us. Now let's pay attention to the last integral, c. In this case, we have a sine theta to the 5th power. And of course, we're also going to use power reduction technique for this one. And a little more of what we already know. Now evaluating at the intervals. Wait a minute, do you remember this identity? Wow. It still applies here. So check it out. This is cos pi minus pi over 6. So since we already know cos pi over 6, we have its result. All these should multiply. Meanwhile, these two minus signs can go and rest. And a little reduction. Remember that cos pi over 2 is 0. The left hand gave me 4 multiplying root 3 minus 50 root 3 all divided by 10. And the right gave me 512 over 15. Now simplifying, we'll get the mean value of the integral c. Now let's go back to our original question. To the integral, remember we said that s equals a minus b plus c, which we wrote down here. So we're gonna do some substitutions now. Alright, so this is the value of integral a, so we'll just substitute it here. I have minus 2 root 3 plus 4, and then minus that of integral b, which is this negative 12 root 3 plus 64 over 3. So we'll just insert it here. And then the value of the last integral, which is c, this one. We'll just insert it here and add it up with the rest. So let's do a little bit of rough work here. Almost there. Bam! We're through with solving this question. So all these tricks and steps were just to prove that this sum is equivalent to this solution. Hope to see you next time on my next video. Thanks for watching.